Before we talk about our last topic in Chapter 5, I want to remind you of something we learned earlier in Section 5.2 when we discussed the complement of an event. So right here we had the complement of an event is all the outcomes that are not in that sample space. And if you recall, down here at the bottom we had this example here where the event E was having both girls, i.e. GG. Then the complement means you're not having both girls. And that means you have to have at least one boy. Right? Now we're going to use this idea to be able to find the probabilities of at least. When you want to find the probability of at least one something, right? Then what you're going to do is you're going to find the probability of 0 somethings and subtract from 1. And this is because of the complement rule. So you're using the complement rule, okay? In case you didn't notice that. Okay, so suppose you are asked to select 3 cards at random from a standard randomly shuffled poker deck, right? Just a normal regular poker deck. You want to know the probability that you select at least one spade. See those words? At least one. That is like a red flag. You should see, oh, at least one. I want to find the probability of none and take it away from 1. Okay, so let me bring this up here for you guys to see. So the way to do this is you say, look, if I want the probability of at least one spade, then what I want to do is take 1 minus the probability of no spades. I don't want a spade on the first card, and I don't want a spade on the second card. I want no spades at all, and I'm drawing 2 cards here. I think it's 2 cards. Let me double check that. Oops, we're doing 3 cards. Nope, my bad. Hold on. Wrong one. Hold it. No cards on 3. All right, so no spades at all. So I want no spades on the first, no spades on the second, no spades on the third. 3 cards, I don't want any of them to be spades. So that means that, do you see how this and is kind of hidden in there? Remember I told you earlier, back, a couple pages ago, that and hides in unusual places. See this word none right here? When you want none, what you're really doing is an and problem. And that means you're going to use the multiplication rule that we learned right here on this page. And in this case, right here. So I want none of them to be spades. So let me go back here. Oops, sorry, I went too far. So I want none of them. So this and turns into this little dot right here. So I'm multiplying. I want no spades on the first card times no spades on the second card times no spades on the third card. And I'm multiplying them because it's an and. It's a none. No spades, none. That's an and. All right, well, the chances of you not getting a spade is 3/4. Or if you want, you could say it's 39 over 52 if that makes you happier. There we go, I've got that in there. But 39 over 52, spades are 1/4 of the deck. There are 13 spade cards, right? So if there are 13 spade cards, then there's 39 non-spade cards. As a matter of fact, let me go up here and kind of just put that in real quick. So for one card, then the probability of a spade is 13 out of 52. So the probability of not a spade is 1 minus 13 out of 52, and that's equal to 39 out of 52. So this is for one card that I'm talking about up here, right? Which isn't the actual problem. I'm just kind of setting up for myself. So for one card, the probability of a spade is 13 out of 52. The probability of a not a spade is 39 out of 52. Then down here, I'm talking about for 3 cards. There we go. For 3 cards right here. And that's what the problem's actually asking about, right? So for 3 cards, how does that work? Well, I want no spades, so I don't want a spade on the first one, I don't want a spade on the second one, don't want a spade on the third one. What I'm setting up for you up here with this 39 over 52 business is I'm explaining to you where I got the 39 out of 52 right here. So I get that from the fact that I want the first card to not be a spade and the second card to not be a spade. So that gets underlined. And then the third one to not be a spade. So I'm using the same logic that I found up above to find each one of these individual cards. So each individual card I don't want to be a spade. That means collectively it's 39 out of 52 for the first one, 39 out of 52 for the second one, 39 over 52 out of the third one. And that's because each individual card has this probability working for it right here, the 39 out of 52 right there. So that's where these 39s out of 52 came from, but I have to do 3 of them because I'm drawing 3 cards. Up here I'm only talking about 1 card, right? So 3 cards, I've got to multiply them because there's an and implied. And just to make my life easier, I knew that 39 out of 52 was 3/4. So, because that's 3/4 of the deck. So I just did 3/4 times 3/4 times 3/4. That's 1 minus 27 out of 64, which makes 37 out of 64. If you'd like, you can use the calculator to do the one with the 39s. So you can say parentheses, actually, you don't even need parentheses. No, I'll do it. Parentheses, math, no, not math, alpha F1, pick number 1. And you can say 39, arrow 52, move your, and then get your parentheses out here, then take it to the 3rd power. So that's 27 out of 64. See? Same thing that I just came up with down here. So the calculator's backing me up here that it's 27 out of 64. Then I take 1 minus that. So 1 minus that answer, enter. And I see it's 37 out of 64, which is what I have right here, 37 out of 64, which is technically a correct answer, but if they want a decimal, it's 0.5781. All right, so it's a little bit complicated, but you find for 1 card first, just kind of set yourself up. Spade is 13, non-spade is 39, both out of 52. Then you deal with the 3 cards and you multiply, right? And then you take it away from 1 in order to do what they asked, because you're going to find the probability of no spades and subtract from 1. And that's what we're doing right here. We're finding the probability of no spades and then subtracting from 1. All right, what about down here? We're going to select 2 graduates, so that'll be nicer. What is the probability that at least one of them, see that? At least one, that's again like a red flag to a stats student, at least one of them was getting a certificate. Okay, so getting a certificate's right here. So let me start with that. Okay, so for 1 student, just for starters, the probability of certificate is 0.2117, right? The probability of not a certificate is 1 minus 0.2117, which is 1 minus 0.2117, 0.7883. And again, this wasn't what we were looking for. This is just kind of a setup right now. So for 1 student, that's how it works. Okay, now what about for 2 students, which is what they were actually asking about? For 2 students, okay, I want the probability of at least one of them getting a certificate, right? So that's the probability of at least 1 cert. So what I'm going to do is I'm going to take the probability of no cert and take it away from 1. So that means I want the probability of the first one not getting a certificate and the second one not getting a certificate. And that and in there really means it's timesing. Remember that the word no or none means multiplication rule. It means you're going to have to times it. So you take that 0.7883 we just found and you multiply it. 0.7883 times 0.7883. This will be the first student not getting a certificate. This will be the second student not getting a certificate. And you multiply the 2 of them. Once you have that, you'll have the probability that none of them have certificates. And then you take it away from 1. Just for fun, I want to know, what is 0.7883 squared. So that's 6214. So it's 1 minus 0.6214. That is the probability that nobody gets a certificate right there. That probability and this probability that I'm talking about right up here, they are the same thing, right? And then I take it away from 1, and I'll have my answer, which is 0.3786. And there I have it all filled out on this page. So for one student, it was this, see, and that's where this 0.7883, I'm using that later on. Let me give it kind of a unique symbol here so you can see it. I'll give it like an arrow thing. So that 0.7883, I'm using down here. That's where this comes from for not certificate. That 0.7883 in there, that's that same value. So I'm first finding the value for 1, and then I'm using it to find the value for multiples, 2 of them in this particular instance. So I multiply them, and that'll get me both of them, the chances that both of them are not certificates. And then I'll take it away from 1 to find what I was looking for, which is at least one of them was a certificate. So it's a little bit complicated, but you can work your way through it if you always keep track of what you're working on and what you ultimately want, which is the probability of none take away from 1. So 1 minus the probability of none, if you will. And always remember the probability of none is going to involve the multiplication rule. All right, we're all done with section 5.3. I'll see you back here for more tutorials and lectures.